So let's analyze this displacement time graph. Here, displacement is plotted on y-axis while time is plotted on x-axis. And we should know that slope of displacement time graph represent velocity. So here, if you see this initial point, why I am saying this initial point? Because here time is 0. So at initial point, you can see that slope is 0. So I can say initially slope, initially slope is 0. And what is slope? Slope is velocity. So I can say that initially velocity is 0. So let's assume that at t is equal to 0, that is initially, our particle was at x is equal to 0, that is origin. And we know that since slope is 0, its velocity is 0. So this is the information that we get from slope at this point. But now I am asking one question, that slope and hence velocity is 0 at this point. But can you say that acceleration of this particle is also 0 at this point? You will get answer of this question in this video itself. So now let's see here. If you see here, slope is positive and let angle be equal to theta 1. So at this point, I can say that slope is positive. And what is slope? Slope is velocity. So this positive sign indicates that particle is moving towards plus x direction. So after some time, let this time be equal to t is equal to 2 seconds. Let it be. So at t is equal to 2 seconds, at t is equal to 2 seconds, its velocity is positive. Velocity is positive. That means that particle is moving towards right. Now, initially particle was at rest, and after some time, that particle was moving towards right. So from here, I can say that force should be acting, net force should be acting on particle towards right. And whatever is direction of net force, that should be direction of acceleration. So this particle is accelerated towards right. That means at this point, you can say velocity is 0, but acceleration is positive. Acceleration is not 0. Acceleration do have some value. Since acceleration, what is acceleration? Acceleration is change in velocity upon change in time. So can I say velocity is changing? Of course, velocity is changing. Here particle was moving towards right and here particle was at rest. So velocity has changed. If velocity has changed, I can say particle is accelerated. So at this point, velocity is 0, acceleration is not 0. We have acceleration to be positive, that is acting towards right. Now, let us further analyze this question. If you see this slope is increasing with time, I'm drawing tangent here. So this angle theta 2 is greater than theta 1. So theta 2 is greater than theta 1. So of course slope, that is tan theta 2, is also greater than tan theta 1. So I can say slope is increasing. So again, my another observation is slope is increasing. And what does it mean? Slope is increasing implies its velocity is increasing. What does it mean? It means let this time be is equal to t is equal to 4 seconds. So I can say that let my particle initially was at rest at t is equal to 0, its velocity was 0. Then at t is equal to 2 seconds, that particle, let it be moving with some velocity, say 3 meter per second, at t is equal to 2 seconds. But I am also saying that its velocity is increasing. What does it mean? It means after some time, let that time be equal to 4 seconds. So t is equal to 4 seconds. Its velocity is increasing. That means from 3 meter per second, it may have reached 5 meter per second or 6 meter per second or 7 meter per second. So practically, what does this graph indicate? Assume that this is car. So initially at rest, then you press accelerator. So its velocity starts increasing. So this is displacement time graph of such case.